Hello, High Point Physical Science class. This video is going to help you do some calculations with mechanical and mass energy. So first we're going to talk about mechanical energy. So think of something mechanical that you can actually see doing something or having energy. Starting with mechanical potential energy. Mechanical potential energy is the energy due to the physical position. So you can see a physical position. The most common example is gravitational potential energy. So this is the energy that is going to have an object and it's going to be acted upon by the force of gravity. So in order to be acted upon by the force of a gravity, remember the train, it was at the top of a hill, it has to have a certain height. So for a gravitational potential energy calculation, we need to know the mass and the height. How do we determine the height is above a zero reference? If it's a reference, that means the scientist, you get to choose where zero is and measure from that point. So you need to know the mass and the height above a zero reference height. Think of it this way, the gravitational potential energy of an object changes as its height changes. The higher, right, the greater the height from the zero reference point, the more potential energy an object will have. Let's do an example calculation right out of your book. So it's on page 113, example 6.1. It says, what's the potential energy of Isaac Newton's 0.45 kilogram apple hanging from a tree at a height of 5.3 meters above the ground? All right, our formula is, let's write this here, gravitational potential energy equals weight times height. Let's focus in on weight first. Once you write that down, weight has to be in newtons, and we were not given a weight. We were actually given a mass. So we need to convert the mass to weight. So think of that. Let's write down what we were given now. We were given mass equals 5.3 kilograms. And we were given height equals, I gotta look at the book here, 0.45 kilograms. All right, so we have our mass. And we have our height. Height's easy, so we can plug that into the formula. But our weight, let's do this. Weight equals 5.3 kilograms. And in order to find weight in newtons, we need to multiply by 9.8. And if you want, you can put the units in, meters per second squared. You don't have to for this problem. Gravitational potential energy equals, we're going to plug in the numbers. Let's plug in the numbers for weight. 5.3 kilograms times 9.8. I'm going to leave the units out so I have room on my board here. Times 0.45 kilograms. I'll put that in parentheses so you can see it a little bit better. As a matter of fact, I'll put all these numbers in parentheses. I'm putting them in parentheses so you can see what they are and you can multiply them together. So 5.3 times 9.8 times 0.45 gives us 23.3. And I'm going to drop the 0.3, because these two measurements only have two numbers, two significant digits. So 23 is our answer, and the units become joules. All right, let's take a look at kinetic energy. Okay, kinetic energy, you remember from your notes, has to do with motion. We're talking about physical or mechanical kinetic energy. So it's the physical movement of matter. So matter has mass. So we know that that's in the formula, right? So So kinetic energy equals 1/2 the mass times the velocity squared. So if we double the mass, we double the kinetic energy. If we double the velocity, we quadruple the kinetic energy. Let's take a look at a sample problem from your book. It's on page 114. It says, what's the kinetic energy of a 75 kilogram sprinter running at 8.7 meters per second? So the mass equals, what's that again? 75 kilograms. The velocity equals 8.7 meters per second. All right, so we want to take these numbers and exchange them or plug them in for the letters, for the variables. So kinetic energy equals 1/2 the mass, 75 kilograms, times 8.7 velocity meters per second squared. All right, so when we do this problem, remember order of operations. We always start with an exponent first. So you need to go 8.7 either squared on your calculator or put 8.7 times 8.7, then times 75, then divided by 2, or times 0.5, either way you want to put it. So I'm going to write that out here. 8.7 times 8.7 times 75, okay? Hit the equal sign before you divide. All right, so that your calculator knows you need to find the I can't remember the name of it, quotient or the multiplicable, I'm not sure. But you're going to multiply all these out anyway. And then you're going to divide by 2 because 2 is in the denominator. All right, so we've got 2,830 is our answer. But again, this has 2 significant digits, and this has 2 significant digits. So I'm going to take that 3 and I'm going to just exchange it for a 0, and I'm going to have 2,800 joules. So 2,830, all right, I'm just going to drop that, and I'm going to make it 2,800 joules. Again, I only want 2 significant digits in my answer because there's only 2 digits in my measurements. All right, and my units are joules. All right. All right, lastly, let's talk about mass energy. Mass energy is, think of Einstein because his formula is going to look familiar to you. It's the largest potential source of energy if we could convert all of an atom's mass completely to energy. So if we could do that, and mass in very, very small quantities does convert to energy. Not an entire atom, but electrons and parts of electrons do get converted to mass. All right, but if we were to take all of an atom's mass and convert it to energy, we would use this formula. Energy, or mass energy, equals the mass times the velocity of light, I'm going to put c squared. All right, so it's mass times velocity. It looks a little bit like kinetic energy, but it's the velocity of light. Electrons travel at the speed of light. Think of it that way. Speed of light, and then of course squared, just like our kinetic energy formula, except there's no 1/2. All right, so go to page 118, example problem 6.3. It says, how much mass energy in joules could be obtained from the complete conversion of a 138 gram media player. Okay, that's a lot of mass being converted. So let's write that down. Mass equals 138. I have to put it over here because I don't have much room. Grams. Notice how we're using kilograms in each of these formulas. We need to make the mass kilograms. So 0.138 kilograms. All right, we're going to move the decimal to the left so that it's now kilograms. All right, the speed of light is 3.8 times, no, 3.7. I have to look it up here. Well, we'll just do 3.0 like the book has. 3.0 0 times 10 to the 8th meters per second. All right. So here's where you need to get really good at using your calculator. We're going to take the mass in kilograms. Energy equals 0.138, and I hope you're doing this on your calculator. All right, type this in and make sure you get it, because here we go. 3.0 times 10 to the 8th, and that will be squared. All right, and then it's meters per second squared, and that's going to give us an answer of 1.24 times 10 to the 16th. Let's see if I have room to write that any lower on the screen. I do. 1.24 All right, so a couple of things you could do. If you're typing this in your calculator, you're going to type 3, you write this here, 3 double E, just the term. Okay, this is your iPad calculator, 3 double E 8. And that will give you this number. You'll see 3 double E at the top, and then underneath that, it'll say 3 times 10 to the 8th. So you do that. Multiply that twice or hit squared. There should be an x squared button on your calculator. All right, so 3 double E x squared will be your next button. Then write times 0.138. All right, so that's how you would use the calculator to get it. Now, think of this, when you are taking one exponent and squaring that exponent, you're actually multiplying the number. So you could change this to times 10 to the 16th and then square the number. So you could do this in your head. 3 squared, I'll write it small here, is 9 times 10 to the 16th, and there you multiply the exponents as well. And then you could also just multiply the 9 times 0.138 and get 1.24, and then just keep that scientific notation. All right, so problems 10, 11, and 12, that is your homework. After you write all this down in your notes, you have to solve for gravitational potential energy, mass, times gravity, times height. So I'm going to write that here. I actually like this formula better. Mass times gravity times height. Notice that's the same formula. I do like this one better because it reminds you to put the gravity in, mgh. Kinetic energy, 1/2 the mass times the velocity squared. And mass energy, mass times the speed of light squared. You'll need to do one of each of those. So rewatch this video if you need to practice before you do the problems in the book. And if you have any questions, please let me know.